Hello, friend, welcome. Where do we stay? We stay on the Earth. Earth stays inside the solar system. Solar system stays in the galaxy. So, today we are going to talk about the galaxies, friend. We are data plagues. We share the value through the information intelligence that creates the value and add the value. So, friend, what is the galaxy? In this, today we are going to see the four sections: overview of the galaxies, types of the galaxies, evaluation of the galaxies, how they form and everything, and what are the large scale structures in the galaxies. So, friend, in the overview, galaxy basics. What exactly the galaxy? So, galaxies consist of stars, planets, vast clouds of gas and dust, all bound together by gravity. The largest container trillions of the stars and can be more than million light years across. The smallest can contain a few thousand stars and span just a few hundred light years. Most large galaxies have massive black holes at their center, some with billions of times the sun's mass. Galaxies come in a variety of shapes, mostly spirals and ellipticals, as well as those with less orderly appearances, usually dubbed irregular, asymmetric. Most galaxies are between 10 billion and 13.6 billion years old. Some are almost as old as the universe itself, which formed around 13.8 billion years ago. Astronomers think the youngest known galaxy formed approximately 500 million years ago. Galaxies can organize into groups of 100 or fewer members held together by their mutual gravity. Larger structures called clusters may contain thousands of galaxies. Groups and clusters can be arranged in superclusters, which are not gravitationally bound. Superclusters, empty voids, walls of galaxies, and other large scale structures make up the cosmic web of matter of the universe. Let us see our Milky Way, the galaxy in which we are. There are billions of the galaxies, and the interesting thing is that we are staying in only one galaxy. My God, it's so amazing to see these things. So, our galaxy is called the Milky Way galaxy. It is the spiral with the disk of the star spanning more than 100,000 light years. Earth is located along one of the galaxy's spiral arms, about halfway from the center of our solar system. Takes about 240 million years to orbit the Milky Way just once. How many years we need? The 240 million years. From the perspective on Earth, the Milky Way looks like faint milky band of light aching across the entire sky, which is now how it has got the name. This feature marks the central disk of the home galaxy seen H. The Milky Way sits in a neighborhood of with over 50 other galaxies called local group. Its members range in size from dwarf galaxies, smaller galaxies with to a few billion stars, to Andromeda, our nearest large galactic neighbor. The local group sits just off the edge of Virgo cluster and is part of Laniakea supercluster. So friends, let's go to the types of galaxies. So galaxy types. The types of galaxies spiral galaxies, elliptical galaxies, lenticular galaxies, irregular galaxies, active galaxies, Seyfert galaxies, quasars, blazars. So, types of galaxies. Sometimes categorize galaxies based on their shape and physical features. Other classification organize the galaxies by the activity in their central regions powered by a supersized black hole and the angle at which we view them. So, spiral galaxies. This stunning view of the spiral galaxy M101, also known as Pinwheel Galaxy, was captured by the Hubble Space Telescope. NASA, ESA, this particular collaboration. Our Milky Way is one of the example of a broad class of galaxies defined by the presence of spiral arms. These galaxies resemble giant rotating pinwheels with the pancake-like disk of stars and central bulge or tight concentration of stars. The spiral arms can be wound tightly or loosely, and some cannot be seen from Earth because we view the galaxy from the side edge on. Spiral galaxies are around by halos, mixtures of world stars, star clusters, and dark matter. Invisible material that does not emit or reflect light but still has gravitational pull on other matter. The youngest star form in gas-rich arms, while older stars can be found throughout the disk and within bulge and halo. Both the Milky Way and Andromeda galaxies belong to a subtype known as barred spirals, which make two-thirds of the group. Barred spirals sport ribbons of stars, gas, and dust that cut across their centers. Scientists think the presence of a bar indicates that galaxy has reacted. Scientists think the presence of a bar indicates that galaxy has reached full maturity. Elliptical galaxies. NGC 2865, shown here in image captured by the Hubble Space Telescope, is an elliptical galaxy located 100 million light years away. Elliptical galaxies have shapes that range from completely round to oval. They are less common than spiral galaxies. Unlike spirals, elliptical galaxies usually contain little gas and dust and show very little organization or structure. The stars orbit around the core in random directions and generally older than those in spiral galaxies since little of the gas needed to form new stars remains. Scientists think elliptical galaxies originate from collisions and merges with the spirals. Lenticular galaxies. Lenticular galaxy NGC 4886, image here captured by the Hubble Space Telescope, contains primarily old stars but no spiral arms. Lenticular galaxies are kind of cross between the spirals and ellipticals. They have central bulge and disk common to spiral galaxies but no arms. But like ellipticals, lenticular galaxies have older stellar populations and little ongoing star formation. Scientists have a few theories about how lenticular galaxies evolved. One idea suggests these galaxies are older spirals whose arms have faded. Another proposes that lenticulars form from mergers of spiral galaxies. Irregular galaxies. The Hubble Space Telescope captured this image of NGC 5264, an irregular dwarf galaxy. Irregular galaxies have unusual shapes like toothpicks, rings, or even little groupings of stars. They range from dwarf irregular galaxies with 100 million times the sun's mass to large ones weighing 100 billion solar masses. Active galaxies. Around 10% of known galaxies are active, which means their center appear more than 100 times brighter than the combined light of their stars. They can be spiral, elliptical, and irregular. The Milky Way is not currently an active galaxy, although it likely experienced a burst of activity in the past few million years. Astronomers think this excess energy comes from areas near the galaxy's central supermassive black hole, which range from hundreds of thousands to billions of times the mass of our Sun. Gas and dust collect around the black hole to form an accretion disk. The black hole's gravity compresses and heat the disk, which causes the material to glow around the multiple wavelengths from infrared to X-rays. Seyfert galaxies. The Hubble Space Telescope captured this image of the spiral galaxy NGC 5728, which is also Seyfert type active galaxy. Seyfert galaxies first identified in 1943 by American astronomer Carl Seyfert are the most common active galaxies and also exhibit the lowest energies. All Seyfert looks like normal galaxies in the visible light, but they emit considerable infrared radiation. When observed in the infrared, some reveal bright emission from the donor-shaped torus. Some also emit X-rays. Seyfert galaxies tend to have lower radioluminosity, although some produce radio jets. Quasars. What are quasars? The Hubble Space Telescope image reveals a bright star-like glow in the center of active galaxy Markarian 23, the nearest quasar to Earth. Quasars are the most luminous type of the active galaxy. They emit light across the electromagnetic spectrum, produce powerful particle jets, and can radiate thousands of times the energy emitted by galaxy like the Milky Way. The nearest quasar, called Markarian 231, is located some 600 million light years away, but we see many more quasars the further we look. Now see the blazars. What are the blazars? Markarian 421 image captured by the National Science Foundation Sloan Digital Sky Survey is one of the closest blazars to Earth. Blazars produce light across electromagnetic spectrum. Their powerful jet point almost directly at Earth, so they appear brighter than other light galaxies. Observatories on Earth can sometimes detect high energy particles like neutrinos produced within the jet, trace them back to their home galaxy. This information gives scientists a glimpse into the environment around the blazar's supermassive black hole. So friends, let's go to the next point, the evaluation of the galaxies. How the galaxies got evolved. So galaxy evolution, formation, spiral galaxy bars, collisions, mergers, galactic cannibalism. So galaxies evolution. In the 2004, the NASA released the Hubble Ultra Deep Field. This image of a small parts of constellation Fornax contains around 10,000 galaxies, some of which existed 13 billion years ago. less than 800 million years after the Big Bang. Snapshots like these allow scientists to study galaxies at different evolutionary stages. It's a bit like taking a picture of all the people in the New York City's Times Square and using it to study the human aging, since it would show the example of people of all ages. But even with all our modern observatories, astronomers still have many questions about exactly how galaxies begin and grow. So this is amazing. Galaxies, 10 thousands of the galaxies together. This is beyond. That's really the amazing, inspiring stuff. So how the galaxies form? Astronomers know that some of the oldest galaxies observed formed when the universe was only about a billion years old. They think those galaxies started to grow around the pockets of the space that were slightly denser than their surroundings, an effect created by cosmic inflation when the universe began. But when it comes to the exact order of information, they have little bit of chicken or the egg problem. That's interesting. So the Milky Way, it is possible that the black hole come first and the galaxies grew around, but nobody knows the exact formation of these galaxies, how they have formed or become. The grandeur of the NGC 1300 about spiral galaxy is clear. This Hubble Space Telescope image, the spiral galaxy bars. Many older spiral galaxies develop a central band like structures of stars called a bar. In these galaxies called bars, spirals, this feature connects the arms rather than the nucleus itself. Collisions. The collision of the galaxies NGC 2445 and NGC 2444 fueled a frenzy of star birth that produced this unusual triangle of young blue stars. Galaxies can collide sometimes. They form out of the collision, the many things get distributed or spread or thrown out, so that becomes the next new kind of galaxies contained with the stars. Mergers. If colliding galaxies don't have enough momentum to move past each other, they can merge to form a single larger galaxy. Merged galaxy can look very different from the two created for it. So friends, the rim of ring galaxy AM 0644741 imaged by the Hubble telescope spans 150,000 light years away. Space is amazing, space is crazy, space is beyond what human just evolved over the last, we can say, 10,000 years, right? As like we are just 2024 right now, maybe whatever the first living organism started, maybe billions or 10 billions or 100 billion years ago, we don't know. But whatever we are now as human psychology, human intelligence get developed, it is just the 2024 years right now, from the zero to now. You imagine this earth, this universe, space exist millions of the years. That's something crazy stuff. Galactic cannibalism. What does that mean? Larger galaxies can also gobble up the smaller one through the proximity and gravitational interactions, pulling the material away to fuel their own growth. Researchers think the Milky Way is currently funneling away a stream of hydrogen from its satellite of galaxies. So this is what we see how the galaxies evolve, friends. Let's see what is a large scale structures called. So in this we will see large scale structures, galaxy groups, galaxy clusters, superclusters, the intergalactic medium, galactic walls, the cosmic wave. Large scale structures. The nearly 10,000 galaxies captured in the Hubble Ultra Deep Field may look like they are randomly scattered across the sky. But the galaxies, including Milky Way, often part of larger structures or superstructures in the space. Galaxies, groups, and clusters are collections of galaxies bound together by gravity. They are building blocks for the larger scale structures. Galaxy groups. Galaxy groups generally hold 100 or fewer galaxies. The Milky Way and its closest neighbors, including Andromeda Galaxy, live alongside over 50 other galaxies within local groups. The Hubble Space Telescope captured this image called the Hubble Ultra Deep Field in 2004 by combining 800 images with a cumulative exposure of 11.3 days. It contains around 10,000 galaxies. What is a galaxy cluster? NASA's Chandra X-ray Observatory captured this view of the massive Perseus cluster, one of the largest known galaxy clusters. The structure contains thousands of galaxies immersed in an enormous cloud of superheated gas. Galaxy clusters contain more than thousands of galaxies inside and stretches over 20 million light years across. What are the superclusters? Superclusters are large collection of the galaxies, clusters, groups, and individual galaxies that are typically gravitationally bound to each other. The local group contain the Milky Way is located on outer edges of the Lanica supercluster. The intergalactic medium. The Caltech's cosmic wave imager captured this image of the quasar 1549 plus 19 surrounded by hydrogen blue and a filament of gas flowing inward from the bottom left. The intergalactic medium is the gas and the plasma, a mixture of electrons and atoms with an electric charge found in a space between the galaxies. It's extremely hot, reaching millions of degrees, but it's also very thin, only about 1 atom per cubic foot. For comparison, the empty space between the two stars may have 1000 atoms per cubic foot. So while the medium is hot. Galactic walls. Groupings of superclusters can form walls or sheets of the galaxies. These walls are likely the largest known superclusters within the observable universe. The cosmic wave. Fly through the cosmic wave the large scale structures of the universe through this visualization. Each bright knot is an entire galaxy, while the purple filament shows the material between them. The human eye, only the galaxies would be visible. This visualization allows us to see the strands connecting the galaxies and forming the cosmic wave. This credit is to the NASA NCSA University of Illinois visualization by Frank Summers. So friend, today we explore the amazing things, galaxies, its overview, its type of the galaxies, evaluation of the galaxies and large scale structures. So friend, if you say, I have some questions. Human life, one life, if you say, its life is maximum 100 or 150 years, we say. This is the time frame of anybody living organism, including the the human, what he sees, this is the time. But these galaxies are so huge, so humorous, so enormous, so big. We will never go there, but human mind, what it shows, this exploration, human minds can think big. It can visualize, imagine very, very big thing. Whatever we have seen, so many galaxies, thousands, billions now, it is just one point now. What right now, if we assume this is just the single point on the tip of the finger, what about the rest space? That is still there. That's the universe. That's the enormous things. That's where we don't know what is beyond those things. What do you think, friends? We'll be glad to know. Comments on this. The reason because this galaxy is very, very favorable topic to me, and I like this more because that is beyond this all. Whatever AI, whatever things are happening, they are just talking right now about the earth, the data here, the people here, and earth is where galaxies, how the AI, how the intelligence can explore, analyze things and help the humans to create the better future beyond in all the circumstances, considering plus, minus, worst, based all the things. So it was great to go through today. Amazing galaxies, friend. The NASA's work is so amazing, so inspiring. We will bring the dataplex, such inspiring things, amazing things, which let us think more, which let us think productive. Let us think the way it has to. The things are so big. Why we have to worry about the small problems? See that problem and overcome the problem. That inspires this. There are millions of the galaxies getting merged, happening, but still they are going out of that situation. Similar for the human life, how these galaxies inspires us more and more and more. Coming generations, future generation, whatever the, I will say the 10,000 billion years or million years, trillion years before this universe is still there. It will be still there after the next trillion or billions or many peta billions years. But what is in all these things? It is a human mind. That is what the essence of all these things. Human mind is the point where this all talks, imagination and visualization is going on. So that's cool, friend. Looking forward to know your comments. What do you think about these galaxies? If I say whatever we discuss, this 10,000 billions of the galaxies on the tip of our finger, what is in the rest of the area? Would we like to know your answers? Thank you very much, friend. See you in the next amazing video.